Hi, my name is Joycelyn Clay, and I will be doing my project on finding the area of two-dimensional figures and their proofs. Part 1 will consist of the two-dimensional figures, defining two-dimensional figures, area, and proof. What is a two-dimensional figure? A two-dimensional figure is a set of line segments, sides, or arcs all lying on a single plane. And they are also classified as polygons because all edges are segments and every vertex is the endpoint of two sides. Here are a couple of examples of two-dimensional figures: a circle, triangle, square, rectangle, rhombus, trapezoid, cone, and a parallelogram. Now we have area. What is area? Area is defined as the extent or measurement of a surface or piece of land. Its standard units include square meters, square feet, or square inches. It depends on what your question asks for. And if not specified, then your answer would always be in square inches. Area came about through Archimedes. Archimedes was a Greek mathematician, engineer, as well as astronomer. And he created Archimedes' method, or it's also called now the method of exhaustion. To evaluate area, he produced formulas to evaluate regular shapes by simply capturing new shapes using shapes that have already been previously established. So for example, to find the area of a circle, he used a pentagon, which is also a two-dimensional figure, five-sided. And each area of the circle touched each segment of the pentagon, segment or side. And he found the circumference of the area inside of the circle and just used the pentagon as kind of like guidelines. What is a mathematical proof? A mathematical proof is a mathematical argument for a statement using deductive reasoning that also supports a potential theorem. So it's just kind of like proving a theory for a mathematical proof. Part 2 will consist of finding the area of a circle, finding the area of a square, and finding the area of a trapezoid, as well as finding the area of a rhombus. Finding the area of a circle consists of A equals pi times r squared, and pi is the approximate value of 3.4. And the radius is, r equals the radius, I'm sorry. The calculation of all of the space inside of the circle's circumference defines what area is of a circle specifically. So we're going to start off with the first proof, which is actually calculus-based. For those of you that have taken probably up to calculus 2, you probably would understand this. So the area is looked at through the radius. The integral of the constant goes from r to 0. 2 times pi equals 2 times pi times t. T, actually, you're going from r to 0, but you put the t down here now because it represents the distance. And it's evaluated to be pi times r squared, which was your original formula anyway. Your second proof is called the onion proof, which was also made up by Archimedes. And it takes the sum of an area by slicing a circle into layers, like an onion, which is the examples right here. All right, so an example of finding the area of a circle. The radius of a circle is 3 inches. What is the area? So we know the radius is 3 inches. Your area equals pi times r squared. So you come down, break down the problem, which would be 3.14 times 3 times 3 So we all know that 3 squared, 3 times 3 equals 9. Oh, make sure to put your units here. So 3 inches times 3 inches, which would be 9 inches squared, which would be evaluated out to be 28.26 inches squared. The inches squared is because you're timing the radius times itself, so it ends up being squared in your final answer. So 28.26 inches squared. All right, and next we have finding the area of a square, and its proof. The formula for finding the area of a square is a squared, and a represents the length of one side. So a equals a squared and this actually is also two proofs. One is calculus based and one proof is called the axioms of area, which I will elaborate on in just a minute. So the first, I'll show you the calculus based over here on the board. The function of x equals a, and you're going from 0 to a. So your integral constant will look like this, a to 0. So coming down here after evaluating it, 1 times a, and once again you're going from a to 0, will become a times a minus 0 times a, which equals a squared. So here it is. So here you have a squared, which was your original formula for the area of a square. Alright, so now we have an example. Calculate the area of a square where the square has 35 centimeters side. So we have 35 centimeters. So your A represents one side. So one side represents 35 centimeters. So now you're going to come down to evaluate, which will be 35 centimeters times 35 centimeters, which will be evaluated to be 1,225 centimeters squared. And that is your final answer for your area of a square. Next, we have finding the area of a trapezoid and its proof. The area of a trapezoid is a plus b divided by 2 times the height. So a represents base 1, b represents base 2, and your h, of course, is your height. So now the proof for your area of a trapezoid. A trapezoid is this figure here. And if you look closely, you have a rectangular base and triangular sides. So each individual area has their own formula that's all combined at the end. So the rectangular base is base 1 times the height. The triangle on the left side is 1/2 times x times the height. And then your triangle on the right side is actually expanded. So your right side of the triangle is 1/2 times the base 2 minus base 1 subtracted by x, which all is multiplied by x times the height, which equals 1/2 times the second base times the height minus 1/2 times the first base times the height minus 1/2 times the x times the height, which you actually find over here. So your right side is just expanded from your left. And so a combination of all three of these segments are all of these combined together, but simplified, it becomes 1/2 times base 1 plus base 2 times h, which was your original equation in the first place. And your example for the area of a trapezoid is you have bases of 10 and 14 inches, and you have a height of 5 inches. So your A equals 10 inches, your B equals 14, and your H equals what? Just stop it. So here you have find the area of a trapezoid with bases of 10 inches and 14 inches and a height of 5 inches. So your A is going to equal 10. Your A will equal 10. Your B will equal 14. And your height, of course, is 5 inches. So now you plug into your formula, which is A equals 1/2 times 10 plus 14 times 5. But order of operations, you're going to handle your parentheses first. So you have 1/2 times 24 times 5. 24 times 5 is 120. And you're going to remain with your 1/2. Then you're going to evaluate. 1/2 times 120 ends up being 60. And your answer is the area is 60 inches squared. Alrighty, now we have finding the area of a rhombus in its proof. Finding the area of a rhombus actually takes many calculations because it's a special type of parallelogram. So we have 3 formulas for the area of a rhombus, which is A times the base times the side, base times the side length. And then we have A equals the diagonal 1 times diagonal 2 divided by 2, which is actually called the diagonal method. And then the last one we have A equals S squared times sine times A. S actually equals the length of any side. The lowercase a is the length of an interior side, and the sine, of course, is the sine function, which is used in trigonometry. All right, now for your proof, you have a rhombus here, right here. And so your rhombus is called ABCD, and you have to prove that ABCD is equal to 1/2 times A times C times BD. So each length, these little dashes here in your rhombus show that each side is equal. So triangle ABC is congruent to triangle ABC by the side theorem, which proves that each side is equal. So your triangle ABC is here, and triangle ABC is here, and you can see they're the same size. So your rhombus ABCD, which is the whole rhombus as a whole, is equal to 2 times triangle ABC, because 2 of these makes a whole rhombus. So each side is equal. And so your ABC is equal to 1/2 times the base times the height, which is equal to 1/2 times AC times BE. Sure, AC and your BE is the height. And that is how you prove the area of a rhombus. All right, now for our example, a rhombus has diagonals of 6 meters and 8 meters. What is the area? So here we're going to use the diagonals method, which is A equals diagonal 1 times diagonal 2 divided by 2. So all right, so using the diagonals method, you're just going to plug in your 6 times 8 over 2 which will equal 48 times 2, which gives you 24 meters squared. All right, part 3 will consist of finding the area of a parallelogram, finding the area of a rectangle, and finding the area of a triangle. All right, finding the area of a parallelogram and its proof. The area of a parallelogram is base times height, and any four side can be chosen as a base. So here's your parallelogram. Okay, any four of these sides can be chosen as a base, but your height must correspond to whatever base you choose. So if my base is up here, then my height will be right here. Okay, and to prove this point, we're going to start with a parallelogram. So the first parallelogram is over here. You guys can't see it, but it looks like this one over here. And all we're going to do is cut off a triangular section, which I did here. And all you're going to do is translate it to the other side, creating a triangle, well, creating the other half of your parallelogram. And that is your height and your base. All right, now we have the example. Find the area of a parallelogram with the base of 12 centimeters and a height of 5 centimeters. So A equals base times height. Your base is 12 centimeters and your height is 5 centimeters. 12 times 5 is 60. So you have 60 centimeters squared, and that's your area of a parallelogram. Alrighty, we have finding the area of a rectangle now, and it's proof. The area of a rectangle is length times width. So of course the L is length, your W is width, and the rectangle is defined as a four-sided flat shape with four 90-degree angles. Okay, and now here is your proof. I have a rectangle over here, but you guys can't see it, so I'll draw it here. So you have a rectangle of, you have your A here, x squared, y, x, and you have your y squared here, x down here, which is kind of like the box method. And so you're going to have your x plus y times your x plus y, which is going to give you the quadratic formula of x2 plus y, x squared plus y squared plus 2a. The left side is going to be the same thing. You're going to subtract both sides, but you're going to come out with 2 times x times y, which is going to equal 2a. Solve for a, you're going to end up with x times y, which is the same thing as your formula with base times height. All right, and our example is, what is the area of a rectangle that has a length of 4 centimeters and 8 centimeters? Well, length times width, your length is 4 centimeters, your width is 8 centimeters. 4 times 8 is 24 centimeters squared, and that's your area. All right, last but not least, we have finding the area of a triangle. And finding the area of a triangle is 1/2 times base times height. The triangle is actually 1/2 of the area of a parallelogram, so that's why the formulas look similar. All right, and here is your proof. I don't know if you can see the triangle. So your triangle's here, B, A, C, and here's your height. And notice that there's a right triangle here. So you're basically just going to take your y times your height divided by 2, your x times your height divided by 2, or you can just multiply y times the height, x times the height, and just divide it all by 2, which is all going to come out to be triangle ABC is going to be equal to your original formula, 1/2 times base times height. All right, for your example, find the area of a triangle with a base of 15 inches and a height of 4 inches. So if your area equals 1/2 times base times height, 1/2 times 15 times 4, and of course you're going to handle your parentheses over here first. So this is 15 times 4 is 60 inches times 1/2, which is basically dividing it by 2, and you're going to come out with 30 inches squared. And if there are no questions, And here are my references, and that's it.